Hello, my name is Wesley. Welcome, if you are returning again, to Python Foundations Session 6, Visualization with MatPlotLib. Like I've said before, if you have not watched the other videos before this one, I invite you to do so. Today, I am going to be working out of Google Colab. If you would like to do the same, simply click this Open in Colab button, and Google will come to the rescue and generate a live notebook while reading the GitHub repo. All right. In this session, we'll be discussing visualization strategies and more specifically, how we can manipulate our Pandas data frames to give us the visualizations we desire. Okay, so while we are introducing a new library today, MatPlotLib, we are going to be accessing some of those features via the data frame object, and we'll see why in a moment. But before we touch the Pandas data frame, I want to introduce MatPlotLib. All right, visualization with MatPlotLib. Let's start by importing our MatPlotLib module. PyPlot is a module of MatPlotLib that provides functions to add plot elements like text, lines, and images. Typically, we import this module like so. So check it out. I've got import. We saw a little bit of this in session 5, right? So we import MatPlotLib, the package, .pyplot, the module, and then we're going to do it with an alias. And the alias we're going to use is PLT. This is just like we had PD with pandas, and as we'll see, NP with NumPy. We're going to have PLT to be our alias with PyPlot, and you'll see everyone follow this basic rule. All right, MatPlotLib is strongly object-oriented, and its principal objects, okay, are the figure and the axes, AXES. But before we get into that, I want us to explore the most basic use case. Okay, so before we fret over the different objects that we typically declare with MatPlotLib, I just want us to, open the box and see how it runs. All right, so in this basic use case, we don't declare the figure and axes object explicitly, but rather work directly in the PyPlot namespace. I'll demonstrate to show what I mean here. I'm going to create a list of X and Y values and plot them with PyPlot. All right, so here's my X's, here are my Y's, and this is the call I'm going to make to PyPlot, right? Remember, PLT is PyPlot. So pyplot.plot, and then I pass the first parameter, which will be my X values, and a second parameter that will be my Y values. Lo and behold. Question. What do we think about the out-of-the-box formatting of PyPlot? What are some things we can do to make it better? Could we make it bigger or perhaps different dimensions? Does anyone recognize that default line color? I'll answer some of these since I'm talking to myself today. I think that on the one hand, we have a very minimalist approach, which is good. Not a lot of chart junk, as we like to call it, with PyPlot out of the box, right? There's no grid markers, there's no minor tick marks. You'll notice that on the y-axis, our major tick marks have a step size of 2, right? So there's this sort of auto scaling feature happening with the y-axis. Like we didn't have to tell it, hey, have a step size of 2s. It figured that out for itself. That's pretty cool. What else do we notice? The default plot type is a line, right? So instead of a scatter point, we see a line drawn between each point. And that default color, it's actually a Tableau color. It's part of the Tableau 10. This is the blue color that Tableau came up with as part of its discrete color set, optimized for things like color blindness and the ability to distinguish between distinct color values. All right, before we make any changes, let's become acquainted with the more appropriate way to work with PyPlot. In this formality, we explicitly create our figure and axes objects. You can think of the figure as a canvas, where you specify dimensions and possibly unifying attributes of its contents, things like background color, border, etc. You then use this canvas, the figure that is, to containerize your other objects, primarily your axes, AXES, and save its context with savefig. You can think of axes as the actual graphs or plots themselves. And when we declare these objects, we have access to all the methods of PyPlot, things like plot, scatter, hist, which we'll see more of in the notebook. You can place many of these axes into the figure container in a variety of ways. The last component of a PyPlot figure are the axis, AXIS, the graphical axis we typically think of, right? X, Y, Z if we're in 3 dimensions. All right, so let's take an example. Plot.subplots returns a figure and axes objects together. We'll go ahead and adjust the figure size with the parameter fig size and set it equal to a tuple containing the X and Y dimensions of the figure in inches. All right, so like I said, plot.subplots returns 2 objects, both the figure and the axes, which we've already identified, and I'm going to capture them under the namespaces fig for the figure and then ax for the axes. This, again, is super commonplace, right? So most of the time, unless you have a good reason not to do it, you will name your figures fig and your axes ax. All right, first 2 parameters we won't get into quite yet. They're actually optional, so I can remove them. But the parameter I will pass here is going to be the fig size, and it's going to be 10 inches wide and 5 inches tall. Nice. All right, to recap, we're going to really double down on this. To recap, by convention, we typically separate our plots into 3 components: a figure, an axis, and their axis. Figure. It is a whole figure which may contain 1 or more axes, plots. You can think of a figure as a canvas which contains plots. Axes. It is what we generally think of as a plot. A figure can contain many axes. It contains 2 or 3, in the case of a 3D plot, axis objects. Each axis has a title, an X label, and a Y label. Finally, axis. They are the traditional axis we think of in a graph and take care of generating the graph limits, right? X, Y, and Z. Moving on. Exercise 1. Adjust figure size. Create a figure and axes using plot.subplots. Adjust the figure size to be 6 inches wide by 3 inches tall. Plot the values of the Fibonacci sequence we defined earlier. And then we have some bonus. B bonus, repeat, this time inverting Y values using list splicing. C bonus, explore other plot.plot attributes using the built-in collab tooltip. All right, so for the interest of time, I'll probably just do A and B, and let's get started. All right, so X and Y are already here for us. They're already defined, so I don't have to deal with that. I'm going to create a figure and axis using plot.subplots, and I want it to be 6 inches wide and 3 inches tall. So what is the parameter for that? I'm going to use my tooltip to remind myself. Let's see, and rows and columns. I don't see it there. Let's see if I scroll down, if it will tell me. I think I've done this before in a presentation where I realized it doesn't actually tell you fig size as a parameter, and here I am doing it again. Interesting. Well, good thing I remember, it's fig size is the parameter we're looking for, and we're going to set it equal to 6 and 3. Cool. And what else did we want to do? We wanted to plot the values of the Fibonacci sequence. So I'm going to grab my ax object now. And with the ax object, I'm going to call the method plot. Remember that ax has all of the methods and attributes that are typically stored under pyplot. Methods like plot. All right, and I just feed it X and Y. Amazing sauce. I will do part C, because this is fun. And you should have garnered this from one of the labs earlier on in the week, this ability to reverse something simply by slicing, right? We just take a negative step size. That's it. Manipulating plot attributes. We can manipulate many parameters of a figure's axes, marker, line style, and color, just to name a few. Each of these parameters takes string values. All right, check it out. So here's a dictionary rather, of marker styles. All right, so an empty string for a marker style creates something that's nothing. You know, we can make stars, we can make carrots, hexagons, squares, lot of options, right? The dictionary of line styles is a little bit smaller, but we have solid dash, dash dot, and then empty, and then some basic colors. All right, I have some code here for us to show how I pulled up these dictionaries, right? So we can see there's the markers, here's where the line styles are stored, and here's where the base colors are stored. Let's see some of these changes in action. All right, so here I'm making my figure axes, right? It's 5 inches by 5 inches, plotting what looks like the Fibonacci sequence. Marker style set to S, looks like that created a square. Line style set to a colon, looks like a dotted line, and then color, check it out. Here's where that Tableau color is stored. It's stored under the namespace tab::blue. So I'd probably change this to green and get Tableau green, orange to get Tableau orange. Pretty freaking awesome. And then we have this random plot. Looks like I just have some random numbers here. The marker style for that is a period. Looks like it creates a small circle. Line style is dash dot. Indeed, that looks like a dash dotted line. And then it looks like I've added a hex color here. That's nifty. So I can create any color I want by using hex code. And in fact, I think that color is Tableau brown, if I'm not mistaken. Yep, look at how those colors match. Cool. If we want to make a scatter plot without any lines at all, we set the line style to an empty string. All right. So here, check it out. I've set line style to just an empty string, and there is now no line in my plot. It's a scatter plot. I've also increased the marker size. Shorthand alias for this is MS, so MS set to 10. What happens when I set it to 100? Ginormo, gargantuan. You may be wondering where those axis labels are. We can set those as well. Nice. And it's under the attribute set_x label. Actually, it's not an attribute, it's a function, right? Because we're opening up parentheses after we call it, and we're passing the parameter, first parameter, which is the label we want to use. So in this case, I'm setting x to order and sequence, and then y just to value, not super descriptive here. Notice I've also set the title, ax.set_title. And again, I'm not going to go into all the different methods and attributes available to us in the MatPlotLib PyPlot namespace, but I'm bringing up to attention the ones that will be most relevant for us to get a suitable plot out of the box. Exercise 2, choose lines, colors, and markers. Recreate the myRandomValues plot with a variety of markers, line styles, and colors. Bonus, can you set the markers and lines to colors belonging to the Tableau 20? Try it with and without hex values. Right? So you saw me do a little bit of that earlier, so we're going to skip over the bonus question. But perhaps I will show you some of these other manipulations we can do. So the task here was to recreate myRandomValues plot with a variety of markers, line styles, and colors. So we're just changing markers, line styles, and colors. Let's give it a go. All right, so here is where I'm making my actual plots, right? So here's my data. We're not changing anything here. Here's my figure axes declaration. I'm setting the title and labels. We don't need to change any of that. We just want to change these lines down here. So I'm going to set marker to period, ls to blank screen, and blank string. That looks okay. Maybe we set this marker to square and line style to dotted line. Maybe this one to, can we make a star? Try it with the asterisk. Sad face, what is this? Oh, we needed to put our colon into strings. Line style again. Let's do, can we do dash dot? Magnifico, marker. Let's try a right caret. Let's see what that does and leave it at that. Makes a right facing triangle. And notice how the colors automatically cycle through Tableau blue to orange to green to red. Amazing stuff. I love it. All right, subplots. Remember that figax equals plot.subplot statement we used earlier? We're now going to use that same approach, but this time the second variable that is returned, what we call ax in the cell below, is no longer an axis object. Instead, it is an array of axis objects. I'm also going to introduce another module, random, to generate some random values. All right, so I will read through this quick note because this is just, it'll be useful later on. In the above cell, we use something called list comprehension to quickly populate a list of objects. In this case, those objects are floats. We won't dive too deeply into that now, but you can think of list comprehension as a more concise way of writing a for loop. So what I'm referencing here are these statements in the cell above. Notice the square brackets. Notice the for declaration within the square brackets. Those are what we call list comprehension. In future cases where list comprehension appears in this notebook, I will include code snippets of the corresponding for loop. So here we go. I'm showing here what that list comprehension was doing in the above cell and how it translates directly into a for loop. On your own time, I suggest playing around with this code to see how the two are exactly the same. Line 5 is simply a faster, cleaner way, not computationally faster, mind you, but a shorter, less code way of writing the expanded for loop. All right, the second thing we'll need to talk about is the grid of the AX object and those first two positional parameters that we skipped over earlier in the notebook. This is the number of rows and the number of columns. All right, so plot.subplots works on a grid, and we can pass to the call to subplots how many rows and how many columns we want in that grid, and then creates the subsequent figure housing those axes. All right, so we can investigate its shape. Check it out. AX has a shape of 2 and 2. We can also look at the contents contained within. All right, so what do we see here? AX is no longer an axis, it's a collection of axes. And they are stored in something called an array, something that we will spend dedicated time on tomorrow. For now, let's relate it to how we were accessing specific elements of the Pandas data frame in session 5. Remember when we used .lock and .ilock? We're going to be accessing the elements within the AX object the same way we were accessing elements in the data frame using ilock, that is by index and separating column from row with a comma inside of square brackets. So check it out. This is exactly like accessing a matrix. So matrix row, comma, column equals element. We have the Pandas equivalent, df.ilock 0, comma 1 would return what? It would return top row, second column, right? Because index starts at 0. Putting this all together, we can create the following. So what we have here, nothing has changed from before, except now AX is an array of axes. And in order to access them, ACCESS, we need to index AX correctly. That is, we need to specify what row and what column we're trying to address, and then we can call the method .plot. Right? And so by virtue of this, I'm able to plot some numbers on the top left, top right, bottom left, and bottom right panels, right? All that's changing here is the way we index the AX object. Amazing. Moving on to exercise 3, subplots. Create a 2x1 figure where the first axis is a plot of the Fibonacci sequence up to the 10th sequence value, and the second axis is a plot of 10 random integers with values between 10 and 20 exclusive. Use different markers, colors, and lines for each plot. And the other notes here are just saying that I have done the number generation for you. Let's go for it. All right, so I've got my 2 plots. Right, so we've declared the figure and axes. We have our numbers. Note, no skeleton code here is given for the figure. I want you to write this code out for yourself. Here's a pseudo code to get you started. Plot the left axes, set the title and axes labels. Title should be Fibonacci sequence. Label should be X values and Y values. All right, so let's go for it. AX. Note that we have 1 row and 2 columns. So because we only have 1 row, we don't have to specify which row, right? So you can think of this now as just a simple list where all we have to do is index which column we want. All right, so note here, I don't have a comma, I don't have 2 numbers, I have a single number. And then we can call .plot, and we'd like to plot X and Y1. Let's see if this works before moving forward. Fabulous, looks great. And let's set the title. So it'll be x0.set_title, and we want it to be Fibonacci sequence. And we want x0.setXlabel to be X values, x0.setYlabel Y values. Wunderbar. Let's just copy and paste this bad boy. right? We're going to do the same thing again, but now instead of indexing at 0, we would like to index at 1. And we'd like to plot y2 instead of y1. And the title we want is my random values. Great, looks amazing. Let's send it to the publishers. Visualization with pandas. All right, so you can tie that up. That was our intro into MatPlotLib. We're now going to dive into pandas. And what you will notice is that all of the same stuff we've gone over still applies to pandas. It's as if the PyPlot library was embedded within pandas. Okay, but why do we want to go through the trouble of using pandas in the first place? Because we're usually wanting to plot not just numbers we make up in the notebook, but numbers from a data frame, right? So this makes it super simple. If we work through the data frame to get to our plots, we also have all the associated metadata of column names, perhaps index labels that can be automatically ported into the plot. More to come. Let's check it out. Let's discover the power of pandas plots. While the objectives of the exercises may be to make certain visualizations, throughout our experience, we'll be using pandas tricks to create the data splices we need. So in the following is a mix of new plotting stuff with pandas data selection splicing stuff. All right, so this is just as much a plotting notebook now as a data manipulation notebook. We're also going to import a new module called Seaborn. It is another plotting library based off MatPlotLib. We're going to use it to pull some stylistic features. All right, so here's my Seaborn. I'm using the alias SNS, again, a common thing to do with Seaborn. I'm also importing IPI widgets to add some interactivity to our plots. We're just going to briefly touch on that at the end. The following few cells should look familiar from the last session. We're going to use some essential pandas methods to get a general sense of what our data set looks like. There are many ways to construct a data frame. As an exercise, you might think of other ways to perform that task here. Right, so in this case, I'm just doing the data frame equals pd.readcsv. We saw that yesterday, or excuse me, in session 5, yesterday. In my universe, it was yesterday, but maybe not in yours. df.shape. We should recognize this as the IMDb data set, right? With 85,000 entries, 22 columns. We can remind ourselves of the column names, remind ourselves of the distributions around the numerical columns. Check it out. We can show how .describe. I didn't give you this trick the other day in session 5, but if we would like to look at only the string or non-numerical columns and see what describe pulls up, we can do so by performing a filter, right? So we learned about filters the other day. What do you think this is doing? If you guessed creates a series of Booleans, you are correct. So df.datatypes equals object is either going to return true or false for every row. We can then use that as a filtering criteria on our data frame, which is what we're doing. Right, so now all of the columns that are returned are object type columns, non-numerical columns. And note how the function of the method describe has changed for this categorical data. And now tells us the number of observations, the number of unique observations, the most frequent observation, and the frequency with which it occurred. Butamus. The first thing we notice is that all the data is numerical that we can pull. The first thing that we notice is that the data that is numerical, we can pull forward from df.describe and get the mean, standard deviation, max, etc. What kind of visualizations do you think of with data like this? So for numerical data, I tend to think of scatter, box plot, histograms. And for categorical data, I think of bar, and you might not have heard of this one, but a sunburst chart. So we tend to think of different things depending on the data type, which is good. Let's check out scatter plots. The way to generate a plot in the fewest keystrokes as possible is to simply call the plot method within the data frame object. Let's take an example. All right, so all I'm doing, perhaps naively, is taking the data frame and calling .plot. So what we'll notice here is that .plot automatically down filters to the numerical columns, right, and plots their value on the y-axis. What's on the x-axis? the index. Yep, right, 85,000 rows. We should recognize that as the index. This gives us a raw view of the data, but here I'd like to introduce some standard plotting steps. Recall the FigAx format we used previously. So we're not going to abandon the steps that we learned before. We still want to declare a figure and axis objects. And the way we utilize them is we pass them in as a parameter in the call to df.plot, right? So here I've got df.plot, and I'm setting the ax parameter to my ax object, right? And just to note, like we could call this whatever we want. So here I'm calling it axes, right? Just to be explicit. Awesome. To make this into a scatter plot, we set the line style to an empty string, just as we saw before, right? And the other thing we want to do is then we want to set the marker to something. Otherwise, we won't see anything generated on the plot. Great. To plot x and y that are specific columns of our data frame, we need to specify them in the call to df.plot. So check it out. All of this is the same, but now what I'm doing is I'm passing in the parameter for x. Here I can be explicit. Right, so those were positional arguments. Here I'm making them keyword arguments. So x will be average vote, y will be Metascore, assigning this to the existing axes, no lines, marker set to a dot, marker size of 2. And we note here that there is roughly a perhaps medium positive correlation between vote and Metascore, which makes sense. I believe Metascore might be from critics and votes from users. Exercise 4, scatter plots with pandas. Make a plot of duration versus Metascore. All right, so I've already created the figure axis object for us. Now we'd like to plot duration and Metascore. So we're gonna do the same thing as we did above, df.plot. We'll set x to duration and y to Metascore. Line style to an empty string, marker to a period, marker size maybe to 2. Let's get rid of that marker size. Oh, right. What did I miss, folks? I missed assigning it to the axes. There we go. Nice. Looks great. Bar plots. One of the more common methods of depicting aggregate data is bar plots. We almost always see these kinds of plots used to display and compare between averages, but sometimes between singular data values as well. All right, so this doesn't change my declaration of the figure and axes. Here I'm doing some advanced group by before sending that data to my call to plot. All right, so let's take a moment before we jump down to deconvolute this. And before we do, let's just interpret the graph. So it looks like I've got countries selected, right? So countries, and then I'm plotting duration, and it looks like average duration. Right, so this is the average duration of movies by country. Looking at this code, I've also sorted those. Nulls will go first, right? So if I did a calculation for a country that maybe had empty fields for duration and the mean was a null value, I put them at the top of that list. But then when I go to plot, I'm reading from the last 20 values, right? So basically nulls don't show up. I'm also filtering for countries that have more than 100 data points, more than 100 instances. Awesome. Awesome, awesome. Cool. Now, there's quite a bit of enrichment topics for this notebook. I invite you to explore them on your own. In this recording, we will not dedicate time to them explicitly, but they're there for you to peruse as you will. All right, so jumping on to our last topic in this notebook, visualization with IPI widgets. All right, I like talking about this because it allows us to show a simple, very simple way to make visualizations in our notebook interactive. All right, here we're going to introduce a very basic use case of IPython's widgets using interact. The interact method, stored under IPI widgets.interact, automatically creates user interface controls for exploring code and data interactively. It is the easiest way to get started using IPython's widgets. All right, so here I've defined my function. You'll notice it looks very similar to what we did before, right? I've got my group by. I'm filtering for groups that have more than 100 instances. I'm grouping by country again, selecting a column that is going to be a variable, which if we look at the parameter field in my plot, is going to take on the value of all columns that are numerical in our data frame. All right, and what we're going to see is interact is going to allow us to choose from that list of values, that list of column headers with numerical data types. Okay, so once that column is selected, I take the mean, right? To be explicit here, I'm taking the mean of the numerical field by a country, and then I'm sorting those values. The default behavior of sort values is to be ascending, right? So small on top, big on bottom. I'm putting the nulls first, so they will be on top. And then I'm grabbing the last 20 values, right? That's that negative slicing. I'm going to the bottom of the returned data frame, grabbing the last 20, and then I'm sending that to bar, to plot in a bar plot. Let's check it out. Cool, so here I've got duration selected, but now I can also select average vote. Soviet Union jumps to the top for user votes. That is interesting. And then Bulgaria, Yugoslavia, Czechoslovakia, Romania. Interesting. So like Eastern European countries have a higher average vote, but they don't have very many votes, right? So here, USA, UK movies here at the top. USA, Germany. Note this, we might want to do some data cleaning here. We've got USA, Germany, and then we also have in the same field Germany, comma, USA, unless there's some implicit meaning in which country shows first. Maybe there is, you know, we're making assumptions here, right? Because here we also see UK, USA again. Interesting, USA showing by itself not until something like 10 countries down. The Metascore, Soviet Union again. Reviews from users. Okay, USA, UK, a lot of reviews from users, reviews from critics. Again, these US, other country collaborations showing up top. All right, so let's break down what's going on with IPy widgets. Normally, I would just set my y variable to a value so that when I call my function, my figure is generated with the corresponding data field. So here's the same exact function again. I'm calling it MatPlot. But now, and remember in the column parameter, my default value I gave was a list. And that list was all the numerical column headers in my data frame. For this, I'm just passing a string. And this is how I would normally set up this function. And then if I wanted to change column in my call to the function MatPlot, I would specify what column I want to see. So for instance, average vote. And then my plot would update accordingly like you see here. Okay, so in contrast to that, we want to give interact a list of values for the user to select from. This is the difference between a regular function and one we might feed into interact. So here's what I want my y values to look like. Y equals duration, average vote, votes, Metascore, reviews from users, reviews from critics, right? And you can see that I was able to generate that list by this select dtypes number, select dtypes method from the data frame object, specifying that I want number type columns. So this down selects my data frame to only a subset where the columns are all numerical. And then I call the familiar attribute .columns to grab the column names, right? So this is how I'm making this list. Awesome. Exercise 5, IPy widgets and figures in functions. In the previous section, we created a single drop-down menu to select our y variable for our plot. Here we would like to do the same thing, but this time for directors rather than country. Filter your data frame for only 5 directors that have 5 or more data points, and only filter your data frame for only directors that have 5 or more data points, and only return the top 10 highest average values. There should be 10 directors in the final plot. When you build the interactive plot, group by director this time instead of country. Nice. And I think I might have already given the answer here. So here, let's just go through. What has changed? What has changed? I've got my figure axis declaration. That's the same, nothing new. And then we are focused on directors this time instead of countries, right? So my initial group by will be by director. The next step is that sample size criteria. I only want to include sample sizes of 5 or more, right? So if I have fewer than 5 movies given by a director, we want to throw them out. So the way I'm going to do that is I'm going to call this method .filter. I'm going to define a Lambda function in here. Okay, if we're unfamiliar with Lambda functions, which I assume most of us are, is nothing crazy. Lambda functions are used if we're going to have a low likelihood of calling the function someplace else. It is a way of writing, similar to list comprehension, a very clean and simple way of writing a temporary function. All right, what is going to be passed into this Lambda function, because we preceded it with a group by, are each of the individual data frames that were created by the split. So if we remember the session 5, when we showed the diagram of group by, whenever we group by a column, we create a new sequence of data frames where the column that we've grouped by has a unique value for each data frame, right? And so that is what is being passed into our Lambda method, our Lambda function rather. And so now this Lambda function X is taking on that data frame object in the group by. And I'm saying I only want to keep data frames whose shape indexed at 0 is greater than 5. Well, remember that calling .shape on a data frame returns both the number of rows and number of columns. By indexing at 0, I am looking only at the number of rows, and then passing applying it to this condition of greater than 5, I'm now only selecting data frames with more than 5 rows. Okay, so this completes the objective of the first group by, simply to do the filter. Once we've done that, the data frame minus the groups that were removed is returned. Okay, so now I have to group by again, and in this time I'm still going to group by director, right? Because this is what we want to group by to meet the criteria for the problem. I'm now going to select the column, the numerical column that I want to perform the aggregation on. In this case, since we're using interact, it will be one of any of the numerical columns available to us. I calculate the mean. I sort the values in ascending. I put the null positions first so that we can get rid of them. And then I'm only going to grab the last 10 highest values. I send all of that information to my call.plot and set the kind to a horizontal bar plot. Let's check it out. Here we go. So it looks like Lav Diaz makes very long movies at 350 minutes. Let's check out average vote. Christopher Nolan with highest average vote, right? So that's our Dark Knight person. And then here's the what I presume to be some of the Soviet directors that were bumping Soviet Union up high on the list. We've also got James Cameron. You know, fingers crossed the new avatars are good. And Tarantino. Maybe Metascore will be slightly different, maybe not. Yeah, Metascore is different. Oh, check it out. We've got Charlie Chaplin on there. Awesome. Cool. And that is it for today. You'll notice that when I called .plot, I specified this parameter here, kind, and set it to bar h. If you want more information on that, visit the enrichment topics, other plot types. We'll go over how to make not only bar plots, but box plots, histograms, kernel density estimates, and even correlation plots. I invite you to check that out. Thanks for visiting. Let's look at the schedule here. No associated lab with today's session, but we do have an associated project notebook. So if you are interested in completing the project notebooks, feel free to go ahead and navigate over to random tic-tac-toe agents. You have all of the necessary building blocks now to complete that project notebook. Thanks for watching.